A charming young man has two girlfriends living in different towns. To visit them, he arrives at a particular station at a random time every day and simply takes the train that arrives first. Now, two trains run from this station, one to each town, and they run equally often, every 10 minutes. But somehow, he ends up meeting his first girlfriend much more often. In fact, 90% of the time. How is that possible? Shouldn't it be 50% when he is arriving at the station at a random time? Let's say the train to the first town, call it A, runs at 10 o'clock, 10:10, 10:20, and so on. And say the train to town B runs at 10:05, 10:15, 10:25, and so on. Now, if he arrives at the station at 10:02, which train will he catch? It'll be the one that runs at 10:05 and goes to B. And if he arrives at 10:06, he would end up taking the train at 10:10 to A, 10:04 train to B, 10:08 train to A. So depending on which of these 5-minute intervals he reaches the station in, he will catch either the train to A or the train to B. Since these intervals are equal, he will have an equal chance to catch either train. But then, how is he ending up at town A 90% of the time? You might want to pause the video and think about it. Suppose the train to A runs at the same schedule, 10, 10:10, 10:20, and so on. But the train to B runs at 10:01, 10:11, 10:21, and so on. What happens now? Now, if he arrives at 10:02, he will end up taking the train which runs at 10:10 and go to A. If he arrives at 10:05, train to A again. 10:07, train to A again. 10:09, A again. Only when he arrives at the station somewhere between 10 and 10:01 is when he will end up catching the train to B. In other words, he has just this 1-minute window to catch the train to B, and then a 9-minute window for the train to A. And this applies to every 10-minute interval in the day. So he will end up catching the train to A 90% of the time, even if he likes both his girlfriends equally. Now, if these were the train timings, who would he end up meeting more?